We will discuss about the instruments which is used for the energy measurement purpose. So, instruments used for the energy audit purpose are primarily there are two types. One is used for electrical parameter measurement and another one is for thermal or mechanical parameter measurement. The key parameters that are used to measure in this energy audit are basic electrical parameters like voltage, current, power factor, active power, maximum demand, nothing but your reactive power and apparent power. Then energy consumption in kilowatt hour or units and frequency, harmonics. So these are the essential electrical parameters that are going to measure for the purpose of energy audit. Then another parameters. So these are called thermal parameters or mechanical parameters that has to be measured for the purpose of energy audit. These parameters are heat flow, radiation, air flow, liquid flow, gas flow, velocity, air velocity or flow velocity, noise, vibration, dust concentration, TDS level, total dissolved solids, pH level, moisture content, relative humidity, flue gas analysis. So when the combustion process takes place, the output is coming your flue gases. So the flue gases may be carbon dioxide, oxygen, carbon monoxide, mixture of your sulfur and oxygen, mixture of nitrogen and oxygen, combustion efficiency. So these are the essential parameters you have to measure in case of energy audit. So these instruments are very portable, handy in nature. So wherever you are going to conduct your energy audit, you can easily take these instruments, you can make the measurements. Now we will discuss about some of the measuring instruments. First we start with what are called electrical measuring instruments. But generally what is called electrical measuring instruments means they are used to measure the kVA, kW, PF, your frequency, reactive power, apparent power, your amperes, something but your current, voltage, etc. So when you are going to take these parameters, usually this audit is carried out under the running condition or operating conditions. So you have to take necessary precautions while taking these readings or measurements. Right? And what are the precautions you are going to take means when you are doing the measurements, you have to use proper dress code. For example, shoes you have to wear. You have to wear your helmet. Proper gloves has to be made. Right? The hands should not be wet at all. Right? And these instruments, when you apply, are handy in nature and also you can clamp type arrangements. So when there is a conducting environments, over that you are going to put such a clamp like that arrangement. So that you need not stop the motor. When the process is going on, you have to carry out the motor. You should not disturb the operating conditions. So that's the important thing you have to carry out. So this is the precaution they are giving. Okay, while you are doing your electrical measurements. Why you are doing is since you are taking reading under the live conditions, there is a possibility of short circuits will be there, overcurrent will be there. So to overcome that only you have to use these parameters. Essentially, you should not take readings over the bare conductors. You have to avoid that one. You have to use your rubber band close. Then, next type of parameters called fire rate. So fire rate is the another type of measurement unit. This is for your mechanical parameters. It is used to test the flue gas sample. So when the combustion process takes place, the output gas is called your flue gases. The flue gas may contain your carbon dioxide or oxygen. We have to find out what is the level of the carbon dioxide and your oxygens. So it is called fire rate. So fire rate it uses the volumetric analysis method. So this is nothing but the small gas pump is there. So when you press this one, the flue gas, a sample is taken and is filled in this chamber. Okay, how we are going to find out how much oxygen is there, how much carbon dioxide is there means the reagent used is called potassium hydroxide. Okay, this is used to find out the amount of carbon dioxide. Similarly, to find out the oxygen level, chromous chloride is used. So this gives the amount of carbon dioxide or oxygen in the flue gases. So this is the application of purifier rate to find out the flue gas, oxygen and carbon dioxide content. The next type of instrument is nothing but fuel efficiency monitor. So this shows the fuel efficiency monitor. It measures the oxygen and the temperature of the flue gases which is coming out of your combustion chamber. The calorific values of common fuels like your petrol or diesel or all common fuels is already fed into the microprocessor, which will calculate what is the efficiency of the particular fuel. It's called fuel efficiency monitor. The next is the combustion gas analyzer, just similar to the previous two cases. So this is also another experiment which is used for the combustion gas analyzer. Here you can measure all these parameters, not only carbon dioxide or oxygen. You can measure all the remaining gas parameters also. But only thing is you can measure only 2 gas sensors at the same time. You can see here only 2 gas sensors can be connected. So only at a time you can measure only 2 parameters. Right. Next, what is called a manometer? So manometer is used to find out the pressure in the gas, maybe in the blower or maybe in the combustion chamber or maybe in the any compressor. Yeah, you can find out what is the pressure level. So this is the arrangement of your manometer and the pitot tube. So this is called your manometer and this is called your pitot tube. It contains a digital flexible membrane is used. It is used to find out the pressure of the air ducts, maybe in the air conditioning, actually AC systems or maybe the blower. Okay, anything. Right. To measure your air pressures, so the manometer contains these 2 points. So here I am going to connect here 2 rubber tubes are going to connect for the inlet and outlet of the gases for the purpose they are going to use. And this is called your pitot tube. The 2 ends are connected to these 2 ends of your pitot tube. This pitot tube is going to connect to where we are going to measure the air pressure. For example, you have a air duct is there means you have to put a small drill of 6 centimeters. You have to insert this pitot tube. So by inserting this pitot tube, the manometer shows the amount of pressure. Okay. So when you are inserting the probes, you have to put tightly. That there should not be any leakage of air. That's the precautions you have to take when you are inserting this manometer with pitot tube. The next type of instrument is called the contact type thermometer. So it is just like the thermocouples, which measures the temperature of furnace or maybe combustion chamber. Right? It can be used to find out the flue gas temperature, water temperature or air temperature. All temperature you can measure. It is a contact type. So you have to touch. This is the touching point. You want to measure the temperature of the water means you have to dip this point inside the chamber like this, which is contact type. Next, what is called a non-contact type? Suppose in this case, if you want to measure surface temperature means you have to go to a leaf type probe going to use. So this is to measure temperature of a gas or maybe liquid where you are going to dip this inside the solution or maybe the gas. Whereas we want to measure the temperature, surface temperature means you are going to use a leaf type. Next, what is called non-contact type means there is no direct contact between your instrument and the object to be measured. It is worked on the basis of thermal radiations. When temperature is emitted from the body, thermal radiations, we also call it infrared radiation, it is emitted from the object that is received by this thermometer. This is called non-contact type. Okay, it is based on the how we are calculating this by know the emissivity of the object. Every body has different emissivity. That calculation have to be fed to. Based on that, we will measure the temperature of the object. Right. Next, what is called ultrasonic flow meters. So it is used to measure the flow in any chamber or maybe any duct, air duct or maybe anything, any flow velocity, fuel flow, anything you can find out what is the flow velocity. So it works on the principle of ultrasonic flow meter. The flow can be measured by 2 methods. Either you can go for your ultrasonic method or you can go for the Doppler method also. So in this case, ultrasonic method is a non-contact type. So it is more advantages. Here they are going to use first is called transit type method, second is Doppler type. Okay, transit diagrams are going to fix two ultrasonic sensors inside this flow tube. Okay, we are going to send the ultrasonic waves. So ultrasonic waves, one is sent along with the flow of the fluid, and another one act opposite the flow of the fluid. The difference between these two, that gives the flow velocity. That gives the flow velocity. Okay, because the ultrasonic signal which is travel along the way, it is moves faster. When it's act opposite bit, the velocity will be lesser. Based on that, the difference that gives the flow velocity. This is nothing but the ultrasonic flow meter. And next type, what is called as speed measurement. Speed measurement also we have contact type or non-contact type is there. In case of tachometer is the contact type of speed measurement. Tachometer. Suppose you want to measure the speed of a motor, means you have to fix this. This is called your contact type. This arm you have to fit in your rotor part. It directly gives the amount of revolutions in RPM. Whereas if you go for your stroboscope type, it is based on the effort called stroboscope effect. When a supply is given both, for example, you can come across the industry when a fan and a light, both are fed from the same supply, means both have the same frequency. So in that case, if the light is made to fall on the rotating object, means since both have the same frequency, the moving object seems to be idle or stationary nature because of the same frequency nature. The same principle used here also. So here it sends the flashes of light at a particular frequency to the moving object. At a particular tuned frequency, the moving object seems to be stationary idle nature. So that frequency matches with the speed of the moving object. Okay. This is nothing but the stroboscope type. The next type what is called a psychrometer. Psychrometer is used to find out the temperature level. You can find out verbal temperature, variable temperature, both using your psychrometer. A simple psychrometer consists of two thermometers, okay, which is mounted on the same case. One measures the variable temperature and another measures the verbal temperature. In case of verbal, means we are going to wind over a cloth. So by moving the verbal temperature that arm, means it comes rise completely very faster rate. Based on that, you can say how much faster it rise, it gives the difference of temperature. One is wet, another is wet. Based on how much it evaporates, the water evaporates in the wick, that gives the verbal temperature. So this is the second type of your psychrometer, which gives both verbal temperature as well as variable temperature. Thank you.